Hi everyone. For the first exercise, we are going to work with Stable Diffusion and look into text to image workflow. So we have developed a tool that um, actually uses our GPU remotely, and we can send prompts to access the GPU card and run the Stable Diffusion algorithm to retrieve some images. And this tool, it's actually a pretty interesting workflow. I will first cover some of the fundamentals, technical details behind it, but I would like you also to experiment with it as well as part of the course. And for this one, here we have a remotely accessed desktop computer that is running CUDA, which is basically using the GPU unit to process Stable Diffusion. And we are actually sending, with this custom Python plugin, we are sending a prompt for this engine. So we can supply any type of input, like using words, keywords for our image, as well as negative prompts. And we also have some custom parameters here, which I will get to in a second. And you would actually have to create a folder. So for instance, you can actually, let's say if you're running this on a PC, you can create a new folder and call it my SD images. And what we will do is right click here to the path and then choose select a directory and go all the way down and choose my SD images. And inside of this folder, you also have to place in a new folder, call it img. What will happen is we will actually generate two copies of the same image. One of those images will be placed here, another one will be placed inside this folder so that you can archive it. But I want you to be able to actually keep track of the type of prompts you're using for this type of exercise. And to be frank, we can also create a data format where you can keep track of the inputs, but maybe you want to do it manually at this phase. So now that we have selected it as a directory, you come in here to the path, right click, select a directory, choose that folder, hit OK, and it will also be able to access that image folder inside of it. So I'm going to reduce the inference for now, and let's hit run. We are sending a request to our remote desktop, and it should be able to give us an image. This is actually what I got. Let's see. This is the image that I got. So what's happening is inside of that folder, you can see that we have generated that image, but also a copy of it is also placed here. So if I keep pressing this, you can also disconnect the seed for now. So let's disconnect our seed, hit run. This will actually randomize the input seed so that you will get a different type of image. And you can right click here, go to settings. You should also choose the same folder here. So if you go to my SD images, open, choose the image, open, and enable auto update and save in file, hit OK, you would be able to see how this refreshes as soon as you hit run. So every time you press this button, this would actually update the image that is generated with our algorithm, and these images will be kept here as a copy in your img folder, but in the main folder you'll be able to see the updated image, right? So we are basically creating two copies. One is for Grasshopper to preview the result, the other one is to archive the result. So if you hit press, I'm actually using a low inference value. This is not generating a satisfying image because inference actually it controls the amount of steps we use for the Stable Diffusion algorithm to generate the image, and the guidance decides on how much influence you want the input prompts to have. I wouldn't change the height and width pixels because these would actually, this is a model that is trained on 512 pixels. So the control you have is basically the prompts, the positive and the negative prompts, the inference and the guidance values, and also the seed. So I'll show you how you can use the seed, but first I'm going to set the inference to be 50. And let's set this again. So you can see it's sending a request. Now this is using 50 steps to actually generate this image. And it used a random seed value. So I'm going to keep pressing here and generate a few more images. Now the advantage here is, as you can see, we are actually getting a result in a few seconds, and we can output as many images as possible. So you can see here, for instance, these are all the images I've recently created, and this is the latest image. And you can also adjust the prompts. For instance, let me actually get rid of the negative prompt, or write some keywords: simple, color, metal, city. And then I'm going to change this to be parametric, facade, panels, geometric, what else? Glass, pattern, and we can also do, let's see, a tractor maybe. Let's try that actually, and hit run. So we should be getting an image that is more on the building scale now, right? So we're not getting an image that is on the city level because I had that as a keyword. So the prompt is pretty powerful in controlling the type of image you want to get from the engine. So let's see the latest one. This is actually a pretty nice result. So it's kind of close to the input, right? So parametric facade, panels, geometric glass, pattern, and a tractor, and I've entered simple, color, metal, city. So it's basically focusing more on the building scale for image generation. And so let's actually focus on another aspect. So I'm going to turn it into Zahadit. I mean, we can actually do other keywords like Le Corbusier, for instance, modernist, columns, white, villa, sawa, and pilotis, band, windows. I think that should be okay. And then negative prompt, we call it parametric, organic, and let's say if we want to type in city, and here let's use forced as an input. So let's see what we get. So it actually gave me an interior, so we can do exterior, exterior, facade. Let's add those as well. So you can keep sculpting the result by changing your inputs. So because I wrote columns, I think it's focusing on the columns, but as soon as we hit a prompt that is, let's say, a seed that's generating us an external view, you can see we're getting kind of more appropriate results. Now, the way to use a seed is actually pretty interesting. It's kind of a deterministic model. So you can, let's say, supply a specific type of seed value, like 500,000. It could, I think, take up to a million seed values. So I'm going to show you how that affects the outcome. So I'm running this on inference 50. Well, I got a result like this. But if I don't change any prompts, any parameters here, and keep the seed value to be the same, and I hit press again, it will actually give me the same outcome twice, right? So there's only minimal change here. Basically, it's kind of overriding small, minute details. So there should be, let's see if we can get a refresh. I think it's keeping the seed value here, so you can actually keep track of how the seed values affect. For instance, let's try this one. 312,995. So if I supply that again, 312,920, what was it? Let's check that again. 995. 995. So that was the seed value. So if I press again, it's going to override the image in the drive folder, but it's basically retrieving the same data. So you can actually improve this. Let's say you found a seed value that you really like. You can rename them, move them to another folder. If you want to create some new variations, you can change the prompts. For instance, let's do, I actually had a typo there, but like colorful facade panels, let's add those in. And I'm going to keep the same seed value, but I'm going to increase the inference to be 100. So it's going to go through more steps for image generation. So I'm going to run this again. So we should get something similar to that image, but kind of a more improved version. So you can see it's not giving us a direct control over the end result, but it's pretty much changing the output that is kind of conditioned with the seed value. So if I press this again, we will get the same image, but you can actually keep the seed if you want to focus on that type of image. You can actually change these. For instance, let me take out PLOT, band windows. Let's keep the forest. Let's take out panels as well. And let's try this too. So it's going to override the same image in the folder. But you can see that it's actually giving us a similar image with little changes, right? So it's the input prompt is actually taking influence over how the final image is generated. You can also play around with the guidance. Let me show you an example of how that affects. So if I, for instance, reduce this to be 2.5, now our prompt should have less influence over the generated result. So yeah, so we kind of similar, like got a similar result, but it's not white. It's not, let's say, as close as the previous image. So I'm going to try another 1.5. So yeah, it's kind of getting back to the original image. Let's actually make it 10 to make a comparison. So yeah, I mean, small changes, but basically your main controls would be the prompt, that kind of generates the image, the negative prompt or negative keywords that you want for the image not to have, right? So I wanted this to be a modernist villa, so I didn't want it to have anything to do with parametric organic city keywords, so I excluded them from the generation. And the inference controls the amount of stable diffusion steps, and guidance basically controls how much influence you want the prompts to have. And the seed value basically helps you control the deterministic output of the stable diffusion. So you can pretty much use this with these inputs. If you right click to path, select the directory here, and then after you generate the first image, right click here, go to settings, and choose the image img.jpg inside of this folder. Enable auto update and save in file so that you can see a preview of the generated image, but you will get a copy of it in the images folder as well. So play around with this and keep forming your prompts and using these parameters, see what you can come up with.